Imagine buying a brand new laptop, right? And you discover it costs, I don't know, $400 more.
Yeah, and on top of that, it actually has less memory than last year's model.
Exactly. And you find out it's all, so a tech giant can build a massive server farm to train an AI that, you don't even use.
Right. It's wild. Welcome to the invisible cost of corporate climate pledges.
I mean, for years, we've been told that corporate sustainability reports are basically just bank statements.
Like, it's just objective math. You track the carbon in, you track the carbon out.
Yeah, but then you peek behind the curtain and you realize that footprint is, well, it's an optical illusion.
Oh, absolutely. You think you're looking at a shrinking carbon footprint. But if you shift your perspective just a little bit, it is expanding at a terrifying rate.
Which is exactly what we are getting into today. So welcome to the deep dive. Our mission for you today is to decode the incredibly secretive and honestly slightly wild world of corporate carbon footprints.
It really is its own world.
It is, and we are pulling from a fascinating set of university lecture slides from a 2026 business sustainability course. It's taught by Professor Mikkel Kostela at the ICMA Center.
Right, and the goal here is to figure out how companies game their climate numbers.
Yeah, and then explore this massive, water-guzzling, power-hungry wrench that has just been thrown into this entire system, which is artificial intelligence.
Because today isn't just about reading a sustainability report. It's about learning how to spot the difference between real climate action and, well, clever accounting tricks.
Definitely. Especially now that AI is stretching the physical limits of every single green promise these companies have ever made. Okay, let's unpack this. Because before we can even talk about how AI is breaking these climate pledges, we have to understand how the game of carbon accounting is actually played.
And the sources make it very clear that it absolutely is a game. It has a very specific rule book called the GHG protocol. And the first hurdle they had to clear was standardization. I mean, a large company emits dozens of different greenhouse gases, and they don't all trap heat the same way.
Like methane, for example.
Exactly. Methane traps vastly more heat in the short term than carbon dioxide. So to make the math work on a single spreadsheet, they convert everything into one metric.
Just CO2e, or carbon dioxide equivalent, right?
Yes. They take the amount of a gas emitted, multiply it by its specific global warming potential, and output what that would weigh if it were just CO2.
Which gives you a single number to, put on a press release.
Exactly.
We all know the basics of how they categorize those emissions. You have Scope 1, which is the direct stuff like the gas burned in the company delivery vans or the fuel burned on site at a factory.
Right, the stuff they directly control.
Yeah. Then Scope 2, the indirect energy they buy, like the electricity powering the office lights. We see companies bragging about cutting those all the time.
All the time.
But Kostela's research highlights just how absurd the math gets when we hit Scope 3.
Scope 3 is the monster under the bed. It represents the entire value chain. That means everything from the emissions generated by the third-party suppliers mining the raw materials, all the way down the line to the customer who eventually throws the finished product in a landfill.
And for typical consumer goods companies, Scope 3 makes up, 80 to 90% of their entire carbon footprint?
Yes.
But for a company like Microsoft, the data shows it's 97%.
97%.
Which brings up a huge logistical problem. Microsoft doesn't have a meter on every single supplier's factory in Taiwan or, I don't know, every customer's Xbox in Ohio. So how are they actually measuring that 97%?
They estimate it using a very specific formula. The basic math for calculating a footprint is taking what they call activity data and multiplying it by an emission factor.
Okay, give me an example of how that works.
Let's say a supplier's factory uses 10 million kilowatt hours of power. The company multiplies that by the average emission factor of the local power grid where that factory sits.
Wait, I mean, if the formula is just activity data times emission factor, a company could run its factory exactly the same way, right? Produce the exact same amount of widgets.
Right.
But they just sign a new paper contract for a greener power grid. Their emission factor drops, so mathematically their footprint plummets.
Yep.
But physically, they haven't changed how their factory runs at all. Isn't that just a massive accounting loophole?
It is a profound loophole.
Yeah.
And it perfectly illustrates the difference between the two most confusing terms in sustainability.
Carbon neutral and net zero.
Exactly. They sound identical to the average consumer, but structurally, they are worlds apart.
I definitely thought they were the same thing for the longest time.
Most people do. Carbon neutral essentially means you look at your ledger for the year, You see how much carbon you emitted, and then you just buy enough cheap offsets to balance the spreadsheet to zero.
So you don't actually have to change your business.
No, you don't necessarily have to change your core business model at all. You just write a check.
Wow. But net zero is different.
Very. Net zero requires actual physical sacrifice. The framework dictates that a net zero company has to deeply cut its real-world emissions first, usually by around 90% across all three scopes.
So you only get to neutralize the tiny, stubborn sliver of emissions that are just technologically impossible to remove right now.
Right. And the offsets they use to neutralize that remaining sliver are highly scrutinized.
Okay.
You have avoidance offsets, which essentially involves paying someone to not do something bad.
Like protecting a forest from being chopped down.
Exactly. But proving that the forest was actually in danger is incredibly difficult, which is why avoidance offsets are notoriously cheap and often overstated.
I see.
Then you have removal offsets, where a company funds actual technology or reforestation projects that physically suck existing carbon out of the atmosphere.
Which I'm guessing is way more legitimate.
Yes, removal is scarce, it's expensive, and it represents a genuine physical change.
Which forces anyone reading these reports to ask what the company's real motive is. And Kostela breaks this down into three categories, right? Value, cost, and theater.
Yes, value is when cutting emissions actually saves the company money, like making delivery routes more efficient.
And cost is when they are forced to spend money to comply with a new government regulation.
And theater's just gaming the numbers to look good. What's fascinating here is that the headline fight is almost always over Scope 3.
Because it's so massive.
Precisely. It gives companies the most room for theater. I mean, if a manager is redesigning a product to use less plastic, they're moving the physical emissions. That's value.
Right.
But if they are just redefining the boundaries of their Scope 3 reporting to miraculously exclude a dirty supplier, that is pure theater.
Or they use intensity targets, which honestly completely drive me crazy.
No, they are very controversial.
Right, because an intensity target means a company pledges to cut emissions per unit of product rather than cutting their total overall emissions.
Yes, which can be very misleading.
It's like going on a diet by switching to a cookie that has 10% fewer calories.
Go a healthier cookie.
Yeah, but then you decide to eat 50 of those cookies a day because you're hungry.
You're definitely not losing weight.
Exactly. You are still gaining weight. You are still pumping more total carbon into the atmosphere, but you get to walk around bragging to your shareholders about your healthy choices.
It's a great analogy. It allows a company to claim a green victory while simultaneously maximizing their manufacturing growth. I mean, the core conflict in corporate sustainability is that capitalism demands infinite growth, but the atmosphere has a strict physical limit.
So companies have spent the last decade mastering this shell game of hiding their emissions, but that illusion is kind of shattering right now.
Because they just plugged into a technology that consumes resources at a scale you simply cannot hide.
Artificial intelligence.
Yes, the physical weight of AI is terrifying. If we look at the projections for 2030, data centers in the United States alone will consume more electricity than the aluminum, steel, cement, and chemical industries combined.
Wait, combined, that's insane.
Combined. To put a number on that, total global data center power demand is projected to more than double, from roughly 415 terawatt hours in 2024 to nearly 945 terawatt hours by 2030.
I mean, to understand why it's so heavy, we have to look at the mechanics of large language models. There are two distinct phases, right? Training and inference.
Correct. Training is the initial build. You are feeding the model billions of data points so it can learn patterns.
And the source material notes that just training GPT-3 took the equivalent yearly electricity of about 120 U.S. homes, and that's an older model.
Oh yeah, the models scale exponentially. Training Llama 3.1 took roughly 16 times the energy of GPT-3.
Wow.
So the training phase is an enormous localized environmental bomb, but it's a one-time cost. The real long-term issue is inference, which is the energy required every single time a user actually prompts the AI to do something.
But Costola's research points out that a single prompt seems incredibly cheap. Like, it's about 0.24 to 0.34 watt hours, which is basically in the same ballpark as a standard Google web search. So why is everyone panicking about inference?
Because of the sheer scale of human behavior. You have to multiply that fraction of a watt hour by hundreds of millions of users asking billions of questions every single week.
Oh, gotcha.
Over the lifespan of a popular model, the aggregate energy used for inference completely dwarfs the energy used to train it. And that baseline math is just for simple text.
Right, like writing an email.
Yeah. But if you ask a reasoning model to solve a complex coding problem, or ask a multimodal AI to generate a 5-second high-definition video, that single prompt can consume 70 times more energy than a simple text query.
And it's not just the power grid either, is it? The mechanism for keeping these servers cool is actually draining local watersheds.
Yes, when servers process these massive AI tasks, they generate extreme heat. And you can't just point a standard air conditioner at a hyperscale data center.
That would definitely not work.
No. They rely on evaporative cooling systems. They essentially run water over hot components, and as the water evaporates, it pulls the heat away.
But that means the water is physically consumed.
Exactly. It's removed from the local reservoir. Researchers estimate that generating a standard 100-word AI prompt can evaporate a 500-milliliter bottle of water.
A whole water bottle.
Yes, that is a tangible physical cost for every single interaction. Global data center water use is projected to hit 1,200 billion liters by 2030.
That is just, I don't know, hard to even wrap your head around.
And it gets worse, because tech companies need cheap land and power, so they're often building these data centers in areas that are already prone to severe droughts.
Seriously, the next time you ask an AI to summarize a long PDF just because you're feeling a little lazy, imagine taking a bottle of fresh drinking water and just pouring it straight onto the sidewalk.
It really does change how you view a simple chat interface.
It really does.
But, to truly analyze this, you have to hold two contradictory facts in your head at the same time. Yes, a data center will absolutely decimate the power and water capacity of the specific town it's built in.
You're right.
But globally, by 2030, even with this massive AI boom, all data centers combined will still only account for about 3% of the world's total electricity production.
Okay, here's where it gets really interesting. Because even if it is only 3% globally, the physical cost of AI is causing a structural shockwave that is directly hitting your wallet right now.
Absolutely.
Like, even if you despise AI, even if you've never used a chatbot in your life, you are paying for this boom.
And this comes down to the hardware bottleneck.
Yeah.
AI models cannot run efficiently on the standard computer chips inside your laptop.
Right, they need GPUs.
Highly specialized graphics processing units, which draw a massive 700 watts of power each. But the processor is only half the equation. The real bottleneck that is disrupting the global economy is the memory.
High bandwidth memory, or HBM.
Yes. And to understand why this matters, think of standard computer RAM like a 2-lane road. It's perfectly fine for loading a spreadsheet or, a web browser.
Yeah.
But an AI model is processing billions of parameters simultaneously. A 2-lane road causes a massive traffic jam. The AI processor needs a 100-lane superhighway to move all that data in and out instantly.
That is what HBM is.
Exactly. It's structurally entirely different from normal memory, built in complex vertical stacks.
And the manufacturing reality of building those 100-lane superhighways is brutal.
Yeah.
I mean, fabricating one bit of high bandwidth memory takes 3 times the factory capacity as making standard consumer RAM.
That's a huge commitment.
It is. But here's the kicker. For the manufacturers, HBM earns 3 to 5 times the profit margin.
And if we connect this to the bigger picture, you see exactly how the global supply chain warped. If you run a giant memory manufacturer like Samsung or Micron, you have a finite amount of factory floor space. So do you use it to make cheap, low-margin memory for a college student's laptop, or insanely profitable memory for a trillion-dollar tech giant's new AI server farm?
You rip out the old machines and you chase the tech giants. And the analysts in Costello's course emphasize that this is a permanent reallocation.
Yes, this isn't like the temporary supply chain glitches we saw a few years ago.
No, this is a deliberate structural shift toward the highest bidder.
Which creates a textbook economic externality. An externality is a cost that a transaction imposes on a third party who had absolutely no say in the deal.
Right, the classic example.
The hyperscalers are acting entirely rationally by buying up all the HBM they need. The memory makers are acting rationally by supplying it. But the combined effect is crowding out everyone else on the planet.
And the financial fallout for everyday consumers is staggering. Because the factories start making as much regular memory, standard PC memory prices jumped 90%.
That's a huge spike.
It is. Apple added $400 to the price of a MacBook Pro just for a memory upgrade. Phone manufacturers actually started engaging in shrinkflation.
Right, where they give you less for the same price.
Exactly. They quietly dropped the memory in their flagship phones from 12 gigabytes down to 8 gigabytes just to keep the retail price from exploding.
Wow.
And this means hospitals are paying significantly more for their diagnostic servers. Small businesses are seeing their IT budgets balloon. You are personally subsidizing the AI boom every single time you buy a piece of consumer electronics.
Which forces us to examine the tech giants driving this demand. I mean, with massive energy grids and global supply chains bending to feed their AI ambitions, they're facing the mathematical impossibility of their own climate pledges.
Right, because the core growth engine of their business is suddenly pulling in the exact opposite direction of their flagship sustainability targets.
You can see this dilemma playing out in real time with the major players.
Yeah.
Look at Microsoft.
They made a massive, highly publicized pledge to be carbon negative by 2030, right?
Yes. But because they are building data centers at a breakneck pace to win the AI race, their actual emissions are up 23% from 2020.
It's a huge leap.
Now, to be fair, they are deploying some genuinely cool tech, like zero water cooling designs, and they are buying up a massive amount of clean energy.
Right.
But at the same time, they are reportedly in talks to build a dedicated natural gas plant just to ensure their servers never lose power.
Google is in a very similar bind, aren't they? I mean, they pledged to reach net zero across all their operations by 2030.
Yet their total emissions are up roughly 51% since 2019.
51%.
Yeah. And to solve the baseline power issue, Google has started signing deals for small, modular nuclear reactors.
Wow, nuclear.
Yes. They need carbon-free power that runs 24 hours a day, which solar and wind simply cannot provide. But crucially, because of this massive spike in emissions, Google recently relabeled their 2030 target.
Relabeled it how?
They now refer to it in their reporting as an ambition-based target.
Okay, I have to challenge this directly. Changing a firm 2030 net zero deadline to an ambition-based target sounds like the ultimate corporate theater.
I see why you'd say that.
I mean, it sounds like they realize they are completely failing the math test, so they're just changing the grading rubric so they don't look bad to investors.
Well, I would actually argue that Google's pivot isn't entirely theater. It is a violent collision with physical reality.
How so?
Look at the timeline. If they genuinely need nuclear power to hit net zero, and small modular nuclear reactors take anywhere from 7 to 10 years to permit and build.
Hitting net zero by 2030 was always a mathematical fantasy.
Exactly. Admitting that the 2030 deadline is just an ambition is arguably more honest than buying millions of tons of cheap, useless avoidance offsets just to claim they hit the target on paper.
So the nuclear investment is a massive long-term cost that provides real substance, but they are using a bit of narrative theater to soften the blow of missing the deadline.
Precisely. They are investing heavily in real-world infrastructure, but they are actively managing the public narrative to protect their stock price while that infrastructure is being built.
But, just as it looks like AI is an unmitigated disaster for corporate footprints, Costello's research introduces a massive plot twist.
Yes.
What if this insanely power-hungry technology is actually the only tool powerful enough to get us out of the climate crisis?
This is the critical upside that gets lost in the panic over data centers. AI is an incredibly powerful tool for systemic efficiency.
Give me some examples.
Sure. If you have a complex renewable power grid with intermittent solar and wind, AI can balance the load distribution in real time far better than any human operator.
That makes sense.
Or it can instantly analyze millions of satellite images to pinpoint invisible methane leaks from pipelines globally.
Wow.
It can rapidly simulate millions of molecular structures to discover brand new, highly efficient battery chemistries in a fraction of the time it would take a traditional research lab.
And the projections on this are genuinely shocking. The International Energy Agency estimates that by 2035, the widespread use of AI across all these different industries could enable emissions cuts that are 3 to 5 times larger than the emissions caused by the data centers themselves.
3 to 5 times larger.
Yeah.
In that scenario, the massive initial carbon footprint of training and running the AI pays for itself multiple times over through global economic efficiency.
So what does this all mean? Because if it sounds too good to be true, it usually is. And the sources point to a massive behavioral countertwist here. It's a concept from economics called Jevons paradox.
Also known as the rebound effect.
Right. And the classic example is highway traffic. Say a city has a highway that is constantly jammed. Cars sit there idling, burning gas, and wasting time.
It's terribly inefficient.
Terribly. So the city planners decide to add 3 more lanes to make driving highly efficient. But because the highway is suddenly wide open and incredibly fast, thousands of people who used to take the commuter train realize driving is now the better option.
Right, it's easier now.
Exactly. Within a year, the wider highway is completely gridlocked again. The sheer efficiency of the road invited a massive spike in consumption.
And that is exactly what we are watching happen with artificial intelligence.
Yeah.
The underlying hardware and software are improving at a breathtaking pace.
Getting more efficient.
Yes, the energy required to process a single, standardized AI task is dropping by an order of magnitude every single year. The chips are getting dramatically more efficient.
But we aren't using that efficiency to save power. Because the compute is getting cheaper and better, we don't just do the exact same amount of work for less energy.
We invent entirely new, incredibly heavy tasks for the AI to do.
Exactly. We stop asking it to generate a paragraph of text, and we start asking it to render a fully scored, high-definition movie from scratch.
This raises an important question for anyone evaluating these companies moving forward. Is a company's AI deployment demonstrably saving more energy across their supply chain today than it is burning in their server farms?
Or are they just selling us the theoretical promise of future global savings to justify the massive, very real emissions they are pumping into the atmosphere right now?
That is the ultimate question for the next decade of corporate sustainability.
It really is. So, to recap the journey we've taken you on today, we started by tearing up the idea that a carbon footprint is objective math. We learned how the GHG protocol works and how companies use scopes and grid contracts to obscure the reality of their emissions.
And we explored the staggering physical reality of AI.
Right, how evaporative cooling is draining local water supplies, and how the specialized manufacturing of high-bandwidth memory permanently shifted the global supply chain.
Driving up the cost of everyday consumer electronics.
Yep. And we watched tech giants like Microsoft and Google struggle to balance the soaring energy demands of their AI ambitions with the strict net zero pledges they made just a few years ago.
It's a deeply complex ledger. AI is undeniably a fast-rising load on the world's physical resources, but it is simultaneously one of the most powerful systemic efficiency tools humanity has ever created.
It really is a double-edged sword.
It is. The job of a manager, an investor, or an informed citizen is to look past the press release, look past the ambition-based theater. You have to judge the net effect on physical reality.
And that leaves us with one final thought. Building on this idea of Jevons paradox, we know that AI makes individual tasks incredibly energy efficient. It completely removes the friction from doing work.
Right.
But if it suddenly becomes practically free and effortless to generate a massive data report or write 1,000 lines of code or create a video, human beings aren't going to just stop working and go home early.
No, we never do.
We might just generate 1 billion times more tasks and demand 1 billion times more data than we ever would have naturally. So are we actually automating ourselves into a highly efficient, clean future?
Or are we just accelerating our way into a permanent energy deficit that we can't possibly innovate our way out of?
It's something to think about the next time you decide to outsource a simple, everyday thought to a massive server farm hundreds of miles away. Because when it comes to the footprint we are leaving behind, there is no accounting trick that can save us. The physical trapdoor is real. Thanks for taking this deep dive with us.